the force exerted on a confined fluid. If there is a piston, with a weight of 10 pounds, acting on a confined fluid. If a load of 990 pounds is attached to it, the total force exerted on the fluid would be 1,000 pounds. If the area of the piston that applies the force is 10 square inches, the amount of pressure exerted on every square inch of the piston would be 100 pounds per square inch. Pressure is defined as force per unit area. Therefore, pressure equals force divided by area. Force equals pressure times area. And area equals force divided by pressure. A way of remembering the formulas is by using a triangle with force, pressure and area in the appropriate spaces. Covering up the one you want shows the formula required. Force equals pressure times area. Pressure equals force divided by area. And area equals force divided by pressure. What creates the pressure in a hydraulic system? Is it the pump, the pressure relief valve, or the load? Increased volume equals decreased pressure. By increasing the volume within the pumping chamber, a pressure less than atmospheric pressure is produced, and a partial vacuum is created. As the volume increases, the pressure decreases, and atmospheric pressure forces oil into the pumping chamber. Air can be drawn in through leaking joints on the suction side of the pump, producing air bubbles in the oil, which produces a non-positive, spongy action, and the generation of heat. As energy can neither be created or destroyed, it can merely be converted from one form to another. Whenever there is a pressure drop in a hydraulic system, when no work is done, as in this case from 100 bar to near 0 bar, heat equivalent to the power of the electric motor, 10 kilowatts, is produced. The relationship between actuator speed and flow rate. In this example, the stroke length of the piston is 2 feet. When 1 gallon of fluid fills the cylinder, the piston moves a distance of 2 feet. Thus, the piston covers a distance of 2 feet in 1 minute. Hence, the rate at which the piston moves is 2 feet per minute. Using an infrared thermometer, the operating temperature of the pump can be confirmed. If the temperature is high, this could indicate the pump is worn. However, this would not accurately indicate the degree of wear and loss of efficiency. Volumetric efficiency. The volumetric efficiency of a pump is calculated in stages. Initially, establish the theoretical flow rate using either the geometric displacement and speed of the pump, or base it upon the flow rate at 0 pressure. Induce a load on the pump at various pressures, up to the pump's maximum working pressure, and record the flow rate. Using the formula, calculate the efficiency at each pressure induced. Volumetric efficiency equals the actual pump flow rate divided by the theoretical flow rate times 100 divided by 1. the theoretical flow rate of the pump being tested is established. As shown, at zero pressure a flow of 64 liters per minute is produced. Using the loading valve, the pressure is increased to 100 bar. As shown, a flow of 62 liters per minute is produced at 100 bar. The volumetric efficiency of the pump at 100 bar is 97%.